Hi, this is Tacker 102 Beyond VNF Lifecycle Management. I'm Bob Haddleton from Nokia, and this is Sripriya from Brocade. We're going to do a quick overview of the status of the Tacker project. I'm going to go through some history and how we got to where we are today, and Sripriya is going to give the details of the features in Newton. So a quick project overview, look at the architecture, recap of where we've come from, and then the specific features in Newton, forwarding graphs, monitoring remediation, and then a roadmap going forward from Okada and beyond. So Tacker is a Tosca orchestration platform. It models policies and templates, lets you create VNFs and connect them together, does basic lifecycle management, network services, and VNFs, has resources like VNFs, VNFDs, forwarding graphs, and manages virtual infrastructure. It has a plug-in driver framework to do things like custom drivers for VIMs, custom monitoring and management interfaces, and things like that. A quick overview of the project. This is sort of a process diagram more than a functional diagram. The basic data model is focused around Tosca, VNFDs, NSDs, and forwarding graph descriptors. The input for that comes from the NFV and Oasis Tosca organizations. Those data models are used by Tacker, parsed by two other projects in the OpenStack ecosystem, the Tosca parser and heat translator projects. The output of that heat translator is then passed down into OpenStack itself to do things like manage compute, networking, storage, and all of the resources associated with a VNF. A quick look at the Tacker community and how it's evolved over the past few cycles. Liberty release, Kilo and Liberty release obviously was much smaller contributor base. The project originated out of Intel and Brocade, and into the Mitaka and the Newton cycles has brought in a lot more contributors and had a lot more features and interest in the project. This is a quick overview of the Tacker architecture. High-level API interface used by the CLI and Horizon. Contains an NFV catalog to store the VNF descriptors, the VNF forwarding graph descriptors, and coming up soon will be network service descriptors as well. Those are basically all Tosca templates that are maintained in the catalog. Two major components in the architecture. One is the NFVO for service orchestration. The other is the VNF manager. So the NFVO side handles things like multi-site interfaces to multiple different virtual infrastructure managers, Tosca workflow, the forwarding graphs, and then the VNF manager handles more of the monitoring of the VNFs, alarm monitoring, event auditing, and all those functions. Both of those modules interface into the infrastructure driver, basically talking to heat in OpenStack, and we can support multiple different OpenStacks for orchestration at a single time. So now I'm going to hand it off to Sripriya, and she'll go through some of the features from the past few cycles and for Newton.
Thanks, Bob. So let's do a quick recap of some of the pre-Newton features that were integrated in Tacker. So we started out as a service VM project in 2015. So from there, we first had our Kilo release with basic VNF lifecycle management support, which supported CRUD operations on VNF and VNF descriptors. And along with that, we also had the configuration and management framework support, where the user can bring in their own custom drivers and allow them to be dynamically loaded and configure the VNFs. And in the Liberty release, there were three main enhancements we did. We brought in the monitoring framework, which was very similar to the management framework, where the user can specify specific monitoring policy within the VNF descriptors and allow this monitoring driver to monitor any kind of VNFs. Also, we integrated the Nano standards or the HCE standards into the Tacker API for VNF and VNFDs. And finally, we integrated the parameterization support in templates. What this allows us when a user onboards a VNFD, they can put placeholders to certain parameters, and then during VNF creation, can provide these values in a configuration file that can be applied onto the VNF and do further lifecycle management of the VNFs using the support. And finally, in the Tacker release, we started supporting the Tosca profiles. We integrated with cross projects such as the Tosca parser and the heat translator team. And the next feature we implemented was a multi-site OpenStack support. We wanted to integrate Tacker as a standalone service that can talk to multiple OpenStack sites. And we also support different Keystone versions from V2 to V3. And the other important feature we delivered in Tacker release was the enhanced platform aware VNS. This is specifically for CPU intensive or VNFs with very high specification requirements, and we integrated features such as CPU pinning, NUMA nodes, SRIOV, and we brought in support for these in templates where user can specify these flavors inside the template, and Tacker would go about creating these custom flavors for VNFs with specific hardware requirements. Now let's take a look into the Newton features. The first feature we delivered in Newton cycle is the forwarding graphs. So in Tacker, we introduced the NFV orchestrator plugin to implement the forwarding graphs. We have the VNF forwarding graph API that can take in the descriptor and the descriptor itself as an input, and also the SFC policies that can be described in the template. Once these policies and the specification is provided in the template for the forwarding graph, Tacker then interacts with the lower layers such as the neutron networking SFC component, and that internally has a backend driver configure such as an SDN controller or with a reference driver that is integrated with networking SFC. The Tacker initiates this request to networking SFC by calling the appropriate commands such as the port pair creation, the port pair group creation that are that are further translated within the controller, SDN controller itself, that finally goes about doing the actual operation of creating the classifier functions and also creating the actual chain itself. Other than this, the Tacker forwarding graph API validates the forwarding graph templates, and it also supports lifecycle management of the forwarding graphs, and it fetches the required information for using the VNFs in the service function chain, such as what kind of resources are associated with a VNF and what is the actual port ID information that is required to create this service chain. So this is one of the significant features we implemented in Newton cycle with collaborating with other projects. So here is a quick look into a forwarding graph template. The two main nodes we need to focus on is the forwarding graph group, which contains some meta information about the chain itself, and also the members, which constitutes the forwarding path elements that need to be part of the forwarding graph. When we closely look into the forwarding path element itself, it has a main policy section under which there is a criteria to specify the classification requirements on what destination port range should it be classified, or any other such ACL match criteria types. And then there is a path information which includes a set of ordered pair of forwarder and capability information. The forwarder refers to the abstract VNF type that needs to be included as part of the chain. And then there is a capability that specifies what is the exposed port, the connection point from the VNF that needs to be part of the service function chain. Once we specify these policies, Tacker goes about deploying this forwarding graph by interacting with the lower layer drivers and with the networking SFC. So the next important feature we implemented in Newton was VNF monitoring and remediation. So with this, what Tacker brought in was alarm monitoring policies into the Tosca templates. A user can now describe monitoring policies such as CPU utilization is greater than 50%, then scale out the VNFs, or CPU utilization is under certain percentage, then scale in the VNFs. So Tacker integrated with the Ceilometer project and also with the heat auto scaling feature. to implement this feature. So what happens is once we have described these policies within the Tosca template, Tacker will internally create the appropriate ceilometer resources inside heat and then trigger the scaling policies for the same. And we have also integrated the manual scaling into this, so user can create a manual scale request to perform certain actions such as VNF scaling. And here's a quick look into the alarm and scaling policies that can be used to define some of the metrics and policies which we just discussed. Let me next go quickly to the lifecycle events and audit log. Here, Tacker now supports auditing and logging of all the VNF and VIM, FFG, all these resources events that are put into a DB, and later the user can query this information to find out about some of the lifecycle events that are specific to certain resource, and this can be consumed by external event stream for further operations to be performed on these Tacker resources. Other than these three main features, we have also integrated numerous functional enhancements that has gone in Newton cycle. We have now brought in a unified Vim driver for each Vim, such as OpenStack, and we are planning to integrate this for VMware and other public clouds. And we have also refactored API interfaces where it can now take in the templates as JSON objects instead of raw strings. And in the VNFM plugin itself, we have added a new API for fetching the resource details. The user can now use this API to find more details on the VNF itself, and then the error reason support, which gives a more elaborate error reason of why a VNF failed. Along with these, there are other general project updates that we integrated. One was the auto config generator, which allows to generate the tacker.conf sample and allow the user to customize this tacker.conf file based on their deployment. And we have also now integrated some Mistral workflows for basic CRUD operations on VNF and VNFD. And now the Tacker deployment is made easy with integration with all these modules such as Puppet, Fuel, Ansible, and PyPy itself. There are a few roadmap items we have for the Okata cycle. We are now planning to integrate beyond OpenStack with VIMs such as VMware, and also integrate with public clouds such as AWS and Google Cloud. We are also planning to support containerized VNFs. There are some challenges. How do we instantiate containers such as VIMs and provide network functions in a microservices cluster of microservices? And the other important features we are working on are the VNF component support, where we wanted to automatically install software components on simple VNFs. And we plan to integrate NSD also into our NFV catalog and make it more comprehensive in terms of the descriptors that are supported, including VNF forwarding graph and VNF descriptor itself. And finally, we want to implement the Tosca CSR support that can allow templates to be associated with metadata and allow Tacker to deploy these kind of CSR files. So a lot of interesting features lined up for the Okata cycle. So if you want to learn more about Tacker and are interested in contributing to Tacker, we have some links to get started with Tacker. If you have any questions, please reach out to us on the Launchpad. And you're also free to join us on the Tacker channel and ask any questions. We'll also meet up weekly on 1600 UTC. So feel free to join into these meetings and give us your input and contribute to Tacker. Thank you.